Okay, welcome back. This is Mr. Woolf. Today we're doing benchmark number 16. I can solve right triangle problems using Pythagorean theorem. Well, the first question is, what the heck is Pythagorean theorem? Well, Pythagoras is the old dude that you see in the pictures below, or at least that's what somebody thinks he looks like. But thousands of years ago in ancient Greece, this guy discovered an interesting property of triangles that turns out to be universally true. We still use it today. That property is right here. It only involves right triangles, so every problem we do here on out for Pythagorean theorem will be with right triangles. That means they have a right angle. And we're going to get into what his theorem says in just a moment. We need to do a little bit of review quickly here. First off, we've got to remember how to square root numbers. And remember, we learned that to square root a number, we have to split it up into its factors. So let's get the pen tool on here. And we know we can split 36 up into, let's say, 6 and 6. Okay? Once we found a pair, we circle the pair, and it comes to the outside of the radical, and whatever's left is in the radical. In this case, there is nothing left under the radical, so we're just left with 6, and that works out because 36 is what we call a perfect square. The square root of 36 is 6, because 6 squared is 36. Okay, and the same goes for 81. 81 is a perfect square. We could split that up into 9 and 9, and we've got a pair right there. So the square root of 81 is 9. Let's say that you wanted to keep going and say, all right, but 9 can be split up into 3 and 3. And 9 can be split up into 3 and 3. And you got a pair of 3's. And you've got a pair of 3's. So that's 3 and 3. And we know 3 times 3 equals 9. So we end up right back at 9 anyway. Okay? And 144 works the same. The square root of 144 is 12 because it is a perfect square. Whoops. Okay, so let's try some that aren't. Try some that aren't perfect squares here. Select my pen. Okay, so 24 is not a perfect square. But we can break 24 up into, let's do 12 and 2. All right, 12 can be broken up into 6 and 2, and we can even break 6 up into 3 and 2. Now, we can't break 2 up, we can't break 2 up, we can't break 2 up, we can't break 3 up, because those are all what we call prime numbers. So we look for pairs. We've got a pair of 2's here, and we've got a single 2 and a single 3. So that means that the 2, because they're the pairs, couples get to leave the radical. Okay, and what do we have left under the radical is a 3 times a 2. So when we simplify, we come up with 2 radical 6. Okay. Let's do one more here. Radical 75, we know we'll split up into 25 and 3. 3 is a prime number, so we can't break it up into any more factors. 25, though, we'll break up into 5 and 5, and there's our pair. So couples get to go on the outside. 5 goes on the outside, and what was left? The 3 was left, and it stays on the inside, so 5 radical 3. If you were to enter square root of 75 into your calculator, you would notice that you get what we call an irrational decimal. In fact, the square root of 75 is 8.6602544038, and that's just what my calculator can hold. That decimal will go on for a long, long time. It's a lot easier if we just write 5 radical 3, and that's an exact answer. So sometimes you'll be asked to give a decimal approximation, and sometimes you'll be asked to give a simplified radical answer. You need to be able to do both. Okay, a little vocabulary. Okay, when dealing with a right triangle, you're always going to have one side that's called the hypotenuse. Hypotenuse, right here. That is always the longest side, and it's always across from the right angle. The other two sides are just called legs. All right, and each leg could be labeled A or B, as long as the hypotenuse is always C. And that will become apparent here in just a moment. Okay, the word hypotenuse comes from two Greek words meaning to stretch, since this is the longest side. So there's a little history for you on hypotenuse. Okay, here we've got several right triangles. Okay, and let's practice finding the hypotenuse. It's really simple. Start at the right angle. So let's start here, and we draw straight across from the right angle, and this side here is your hypotenuse. Okay, draw straight across from the right angle, and this side here is your hypotenuse. I'm going to go ahead and do that for the rest of these triangles. I'm just drawing a line straight from the right angle. Now you'll notice this triangle, the right angle isn't labeled, but we can see that this right here is the right angle. It looks just like the corner of your sheet of paper. That's always a right angle. So we'll go straight across from it. And over here, it's not this angle, it's not this, it's got to be this angle. Okay, so hypotenuse, 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 and hypotenuse. In fact, we could label all of those sides now C. Ooh, I don't like the crayon. Let's use this. C, 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 and C. The other two sides are A and B, and it doesn't matter which is which. Oh, there's the bell. Is it time to go or time to start? Oh, it's a snow day. Never mind. Okay, so A and B don't matter. Just C. As long as you get C on the hypotenuse, you're going to be good. Okay, so here's the Pythagorean Theorem, the definition. If a triangle is a right triangle, then the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Now that's a mouthful, but here's what it looks like. Okay, Pythagorean Theorem is written right here. I'm going to highlight it for you. Okay, so make sure you get that down in your notes. So what this says is the sum of the squares of the legs. So one leg is A, the other leg is B, and we squared both of those, and sum means to add. So we had the sum of the squares of the legs is equal to the sum of the hypotenuse squared. Remembering that hypotenuse is always C. Okay, and we can see here that this side, this leg here is 4. Okay, this leg is 3, and this hypotenuse is 5. And if we square them, well, 4 squared is 16, and there's 16 blocks here. Okay, that's what happens when we square. We do 4 times 4, and we end up with 16. 3 times 3, or 3 squared, is 9. If we add 16 to 9, we get 25, and if we square root 25, we get 5. So we can see that this triangle is a right triangle because a squared plus b squared equals c squared. All right, let's do a couple practice problems here so we can see how exactly this works. Let's see. I don't really like this one, how it's set up, so let's rearrange. All right, first thing we've got to do is label our sides. So let's get our pen here. We know that this is the right angle, so I know that this side over here has to be the hypotenuse, which is C. And that makes this side A and this side B, or I could do B and A. It doesn't really matter. Okay, so if we start with our Pythagorean theorem, let me move these out of the way. If we start with our Pythagorean theorem, we start with A squared plus B squared equals C squared. And I'm sorry about the bad handwriting. I'm using a mouse to write. Then we just plug in. So we've got 11 squared plus 9 squared equals, and we don't know C, so we'll just leave it C squared. Okay? Get out your calculator. Hit 11, hit your squared button. 11 squared is 121. Okay, 9 squared is 81. And we still don't know C squared. Okay? Now, when we add 121 to 81, we get 202 equals C squared. And of course, we don't want to know C squared. We want to know what C is. So how do we go from squared to just C? Well, that's where our square root function comes into play. We square root C squared to get C, which means we have to square root the other side to keep it balanced. And if you put in the square root of 202 into your calculator, you get 14.2. And we'll just round it there because this, again, is an irrational decimal. So now we know this whole side here, the hypotenuse, is 14.2. And the last thing I do is make sure that makes sense. If this side's 11 and this side is 9, does it make sense this would be 14.2? Well, it is the longest side, so yeah, that's reasonable. Okay, let's do one more down here. And if you'd like, you can do the others on this page on your own. Just go back, pause the video, practice them. Let's go ahead and start by identifying the right angle. Okay, now we know the hypotenuse is across from it, so this is C. But you'll notice what's different on this problem is this time we have C, we have A, we're trying to find B. No problem. We're just going to start with the Pythagorean theorem like we did last time. A squared plus B squared equals C squared. Okay, and we're just going to plug in the numbers we've got. We've got an 8 for A. We don't know what B is, so we'll leave it B squared. And we do have 12 for C. Okay, now we'll just solve like a typical algebra problem. 8 squared is 64. B squared stays B squared. And 12 squared is 144. All right. Okay, remembering that we're trying to isolate B, we want to solve for B. Okay, so we're going to subtract 64 so that we can get B by itself. Okay, so over here, 64 minus 64 eliminates. We're still left with our B squared. And 144 minus 64 is 80. Okay, let me extend the monitor here so we got a little bit more room. Now at this point you've got a couple choices as to how to solve this problem depending on what's asked of you. Okay, we can do the decimal form where we would just simply square root each side using our calculator. And if you put in square root of 80 into your calculator, you get B equals 8.9. And that seems reasonable because this side is 8 and this side's 12 and this side should be somewhere about the same. Okay. However, if we wanted to simplify that radical, we would again split it up into its factors. Well, I'll use 16 and 5, and I like using those two numbers because 5's prime and 16 is a perfect square. 16 is 4 and 4. There's our pair. So our answer is 4. Pairs come on the outside. Singles stay on the inside for radical 5. Okay, let's just jump here. Okay, here's another problem. If you want to pause it and practice it, that's fine. Here's another one as well. Okay, but what I want to get to is the converse of the Pythagorean theorem. Remembering that the Pythagorean theorem said if the triangle is a right triangle, then the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Whew, that's a mouthful. Okay, so the converse would just be flipping around the if and the then. Okay, so it says if the sum of the squares of the lengths of the two sides of a triangle is equal to the square of the length of the third side, oops, there's a misspelling, then the triangle is a right triangle. So basically what they're saying is if a squared plus b squared equals c squared, then it's right. So here they give us three lengths, okay, and they ask, is it a right triangle? Well, if it is, then a squared plus b squared should equal c squared. Now, how do I know which one is c, 4, 9, or 16? Well, you guessed it. It's got to be the 16 because it has to be the longest side. Okay, so we're going to set it up a squared plus b squared. Ooh, that's an ugly 9. I'm sorry about that. Equals c squared. Well, 4 squared is 16. 9 squared is 81. And 16 squared is 256. Now, it doesn't take a mathematician to see that 16 plus 81 is not going to equal 256. In fact, it's going to equal 97. And 97 does not equal 256. So to answer the original question, is it a right triangle? No, it is not a right triangle because a squared plus b squared did not equal c squared. Okay, here's another one that you can try. Of course, 45 will be your c squared. And here's another one. Actually, here's two problems. Let me separate them here. Yeah, that looks a little better. All right, and you can give those a go as well, but for the sake of time, let's summarize here. First, we talked about simplifying radicals by splitting them up into their prime factors and circling pairs. Pairs come on the outside of the radical, singles stay in the radical. All right, we learned what the Pythagorean theorem was. That's a squared plus b squared equals c squared. Um, we learned what the difference between legs and a hypotenuse is. Legs are the two sides that join to meet the right angle. The hypotenuse is the longest side. Okay, the converse simply says that if it's a right triangle, then a squared plus b squared equals c squared. And last, don't forget to take the quiz on benchmark 16. The link to it is on the YouTube page. And as always, if you have questions, you can text me at my text number, which is right here on the video. Okay, make sure you took notes on this. Make sure you take the video quiz. And if you have any questions, don't hesitate to ask. Okay, this is Mr. Wolf signing off.